Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video and this video series, what we are going to see is I'm going to share all my interview experiences that I had given for the PhD interview, mostly related to the organic chemistry. Okay, so this is the first interview that I had given. It was during the COVID time, so it was online interview. So before starting with what was asked in the interview, there are a lot of questions that come into your mind, that what sort of questions will be asked, whether I will be able to answer it or not, and what will happen further. So without worrying about all that, we must trust ourselves and our preparation of what we had studied in the CSIR NET exam or GATE exam or whichever previous JAM exam that we have given, because they asked, mostly questions are asked based on the fundamentals or the basics. Okay, so let us start. So first they will ask you about the introduction. They will tell you to introduce yourself. So you can tell your name and the institute or the college from where you have done your bachelor's and master's, that is MSc and BSc. And you can also probably tell your interest, why you're doing PhD, and maybe hobbies if they ask about it. Okay, then they will ask you the topic of interest, which is your favorite topic. Okay, they might ask, in some interviews they ask, and in some interviews they don't ask, like what is the your favorite topic from which they should ask questions from. Okay, or which is your topic of research. Okay, that also they ask many times, what was your research interest during your masters, like your thesis was on which topic. So they will ask about your topic of interest, and based on that they will ask you the questions. Okay, and what are the types of questions that they generally ask in organic chemistry? So in interviews that I had given, the questions asked were, let's say there is some reactant A and product B. They will give you the reactant, they will give you the product, and they will tell you to identify the reagents. Okay, this is the first type of question that was asked. Second type, what they can ask is, they will give you a reactant, they will also give you the reagent. Okay, they will tell you to identify the product. Okay, and then after identifying the product, they will ask you questions related to that product, like what is the, how will you identify that using IR or NMR, how will you do the confirmation of the formation of the product using spectroscopy. Okay, or they can ask you questions based on stereochemistry. Okay, stereochemistry. Okay, so these are two questions, and another type of question is direct questions, like in IR NMR, let's say spectroscopy, they can ask you direct values of, let's say, stretching frequency, okay, or chemical shift. Okay, so those values are some of the values that you have to remember. Okay, because without remembering those values you cannot answer this question. Okay, they are memory based. Okay, these are some of the questions, and another question they ask mostly is on reaction mechanism. Okay, the same reaction, they will tell you to write down the mechanism for the reaction. Okay, so let us start. What were the questions asked to me in the spring 2022 paper was, this was the first question that was asked to me. Okay, so here what we have to do is, reactant is given, product is also given, and there are two steps involved in this organic transformation. So you can see here there is N2. So this, if I want to write down in a slightly different way, what is N2, if I open the structure and write down, it would look something like this: double bond N, single bond N, double bond N. Okay, N2. So it is like this. Okay, this is the structure of double bond, then N2, and now nitrogen is forming 4 bonds, so this will be plus. Here there are 2 lone pairs. Okay, negative sign. So this is a structure, the expanded structure of this. So what will happen here is, first you can we know that nitrogen is a very good leaving group. So what will happen, this will move here. Okay, and this pi electrons are delocalized here. So what we are trying to do is, the first step is to remove the nitrogen as a good, as it is very stable, it is a good leaving group. Okay, negative charge is formed here. Now positive charge on an electronegative atom is not stable. So what we do, we break this bond, okay, and nitrogen is lost. What is the structure of nitrogen? N triple bond N, lone pair. Now nitrogen had positive charge. After breaking this bond, it had got its lone pair. That is, nitrogen gas is evolved. And since this group is lost, what will happen here? I will get a positive charge, right? So positive negative will get neutralized, okay, and basically what I will get is a carbene. Okay, carbon having a lone pair and two other groups. This is what? This is which functional group? This is nothing but carbene. Okay, it is an intermediate. Okay, reactive intermediate. So this bond will break, nitrogen will go away as a good leaving group, and we get a carbene. And now what will happen is, the next step is a rearrangement, that is called as Wolff rearrangement. Okay, what happens in this Wolff rearrangement? The group opposite on the other side of the carbonyl, this group will migrate here. This lone pair will come here, and what we will get is a 5-membered ring. 1, 2, 3, 4, 5. Okay, a 5-membered ring. A double bond, C double bond. This is which compound? This is called as ketene. Okay, this intermediate is called ketene. Now this is delta minus, this is delta plus. Now what we can do, you can see here it is an alcohol that is given. So we know alcohol is the reduced product. So we have to form such a functional group which we can reduce to alcohol. So let's say I add what I can add here is, I can add, let's say, water. Okay, so this will attack here and this will open up. What I will get is double bond CO minus, okay, oxygen, hydrogen, hydrogen, like this. Okay, positive charge. Again, positive charge on electronegative atom is unstable, so this will attack here, this will open up. Okay, so what I have got is OH and OH, like this. Now you can see in all, okay, in all we can tautomerize, and what I will get is, I will write here, okay, in all, if I tautomerize, what I will get is a keto group. So this is what? This is a carboxylic acid, and now we know that carboxylic acid can be easily reduced using LiAlH4 or LaH, okay, reduction. Okay, after I do this reduction, what I will get? I will get the final product, CH2OH. Okay, this is the target molecule. Okay, so what were the two steps? The first step was to do the Wolff rearrangement. Okay, first step was loss of nitrogen gas to form carbene. Carbene underwent Wolff rearrangement to form ketene. The second step was addition of water. Okay, quench ketene with water molecule, and you will get carboxylic acid, which further we do reduction using LH, and we got the final product. So this was one of the questions that was asked, and the second question that was asked was this. Okay, that given the reagent was also given, what I had to do is I had to provide them with the product as well as the mechanism of this reaction. Okay, so first of all, you must know this is phosphate ester. Okay, phosphate ester, this is the phosphoric acid, right? So this is an ester of phosphoric acid, so we can call this as phosphate ester. And this is which reaction? This is a name reaction called as Horner-Wadsworth-Emmons, or it is also called as HWE reaction. So this is a reaction which is similar to that of a Wittig reaction. Okay, the only difference is, instead of triphenylphosphine, here we use a phosphate ester. So NaH, we know it is what? It is a strong base, Na plus H minus. H minus hydride is a strong base, so it will abstract this. These are the acidic protons. So this H minus will abstract this proton. Okay, what we will get is C double bond. I will get a negative charge, that is a conjugate base, P double bond O, OET, OET, Okay, now this negative charge will intramolecularly undergo nucleophilic addition. Okay, 6. It will attack here and this will open up. Okay, so what we will get is a 6-membered ring. 1, 2, 3, 4, 5 and 6. So first position we have this phosphate ester P double bond O, OET, OET. Second position I have carbonyl group. Third, fourth, fifth position I don't have anything. Sixth position I have one methyl group and then O minus. Okay, so now what will happen, just like in Wittig, this O minus will now attack the phosphorus. Okay, because oxygen phosphorus bond is very strong. Okay, O, P, O minus, OET, OET. Okay, a 4-membered intermediate is formed. Okay, and then here we have one methyl group. Okay, what will happen next? The next step is this will open. Okay, 4-membered ring will undergo ring cleavage, and what we will get is this P double bond O, O minus, OET, OET. This group will be removed. Okay, loss of this group, and what we get is double bond. Here we will get an alkene. Okay, so this is what this is, alpha beta unsaturated ketone. Okay, so after drawing this product, what they told me is to how do you confirm this product using spectroscopy that this product is formed in the reaction. So the first question was they asked about the NMR. How can you confirm whether this product is formed during using an NMR? So first of all, in NMR you can count the number of signals. Here you can see this will give one signal. This methyl will give another signal 2. This CH2 will give 3. Third signal. This CH2 will give me fourth. And this CH2 will give me fifth signal. So total there are how many NMR signals? In 1H NMR spectrum, 5 signals. Okay, then they told me to predict the values of the approximate values of the chemical shift. Okay, chemical shift. So this one, okay, this hydrogen, here you can see adjacent there is no hydrogens. Okay, so it will give a singlet at which it at 5.85. Okay, so roughly it gives a peak around 4 to 6 ppm. Okay, it is a singlet at 5.85. Okay, now the question is why here you get a lower chemical shift whereas this hydrogen will give a higher chemical shift, because this is de-shielded. How this is de-shielded? Because of the electron withdrawing carbonyl group present adjacent to this alpha hydrogen. Okay, that is the reason why this is de-shielded. Plus this is a sp2 hybridized carbon. Okay, hydrogen is present on an sp2 hybridized carbon. It has percent s character, that is 33%. So that is another reason why it is de-shielded. Okay, then coming on to this signal, this will be giving a singlet. Okay, this 2.09 it will give at this CH3. Again you can see here there is no proton, so that is why it will give a singlet at 2.09. so here actually this is a mixture of two signals. One is a singlet, okay, of this proton, and the adjacent proton, this also gives a similar peak. Okay, because this is a sp3 hybridized carbon and this is also a sp3 hybridized carbon, so the peaks of both these protons will overlap. But for this CH2, what will be the splitting pattern? Adjacent to this, here you can see there are two hydrogens, so this will be 2 plus 1, that is a triplet. So this at 2.09, it is a overlap of singlet plus triplet. Okay, you can see here there are two small peaks and this one peak. So triplet, and then here you can see one singlet. So it is a overlap of two signals. Okay, then we come on to peak at 1.54. Okay, 1.54. Here there are two hydrogens. On the other side also there are two hydrogens. So 4 plus 1, 5. So here you can see it is a quintet. Okay, 4 plus 1, 5. So it is something like this. 1, 2, 3, 4 and 5. So this is what? This is a quintet at 1.54. Okay, and then 3.16. This is the alpha position. Again it is alpha to alpha hydrogen. Okay, next to the carbonyl group. So that is why this is D shielded. Okay, this we will get again adjacent to this. You can see there are two hydrogens. So it will give a triplet. You can see here this is a triplet. Okay, something like this. Okay, triplet. So now the question is, do we have to remember the exact values of the chemical shift? The answer is no. You can remember the rough values like alpha position, the groups, the CH2 at the alpha position. Okay, this protons give a peak at around 2 to 4 ppm. Okay, sp2 hybridized hydrogens attached to the directly attached to the sp2 hybridized carbon, that will give around 4 to 6 ppm. Okay, and sp3 hybridized hydrogen, okay, hydrogen attached to sp3 hybridized carbon, that gives a chemical shift of around 1 to 2 ppm. Okay, so rough values, approximate values at least you must know. Okay, so I gave them the approximate values. And the splitting pattern is obviously very easy, that you must know how to identify the splitting pattern. Okay, how do you do that? It is n plus 1. Okay, for 1H NMR spectrum it is n plus 1. What is the exact formula? 2ni plus 1. Okay, for hydrogen I is what? I value is half. Okay, spin quantum number plus 1. So this will be 2 and 2 gets cancelled, n plus 1. N is the number of atoms. Okay, so you must know how to identify the splitting pattern. And last, they asked me about the infrared spectrum. How do you distinguish using the infrared spectrum? So for this carbonyl, a peak comes at around 1690. Okay, if you see a ketone, normally the peak comes at around 1720 centimeter inverse. But here the peak was seen at around 1690 centimeter inverse. So the question was 1690 centimeter inverse. It is lower. So the question is, why this stretching frequency was lower? Okay, why? Because this is involved in resonance. Okay, we know according to Hooke's law, 1 upon 2 by c root of k by mu. Okay, k is the force constant and the stretching frequency depends on the force constant. Force constant depends on the bond order or bond strength. Okay, bond order also depends on bond strength. So here if you see, it is a perfect double bond. Okay, but after conjugation, if I draw the resonance structure of this, you will see that the carbonyl has got the carbon oxygen double bond has now become a carbon oxygen single bond. So it has got some single bond character. Okay, if I draw the resonance structure, you will see it has got some partial single bond character. So the bond order is decreased. So the K will decrease, that is a force constant will decrease. Okay, so the stretching frequency decreased from 1720 to 1690. Okay, and that was the end of the interview. So in the coming videos also I will share the other interviews. Okay, the same IIT Bombay had given some other the further interviews as well as TIFR and IISER Pune. I will share all those experiences. I hope you have liked this video and you have got some rough idea about how an interview takes place, what are the types of questions that are asked. Thank you so much.